Hi everyone, welcome to the first daily video. This daily video is on unique proofs, or just proofs I don't really see. So the first proof is that -1 times -1 is equal to 1. I have actually never seen this proof before until now, so maybe you're the same. If you're not, just skip ahead. I have another one. Okay, so please follow along. We start with an expression, which is -1 times -1 minus 1. So that's pretty straightforward. Now we're going to factor out a -1 from that expression. So this is pretty interesting. The plus 1 comes from the -1 after the -1 times -1. So, and the -1 comes from just the -1 times -1. And I know that -1 divided by -1 is equal to 1 because everything divided by itself is equal to 1. So we know that -1 plus 1 is equal to 0. So therefore, this expression is equal to 0. And since that this expression is equal to 0, when we add both 1 to both sides, this gives us -1 times -1 is equal to 1, which completes the proof. Proof number 2, the sum of the first n odd numbers is n to the power of 2. So we've definitely learned this in school, at least I have, but like, we don't really see this proof in school too, but it's pretty easy to prove it. We need some basic knowledge for this proof. 1 plus 2 plus 3 plus 4 all the way to plus n is equal to n plus 1 times n over 2. There is a proof for this too that is quite easy, but I'm too lazy to go over in this video. Let's get into it. So first we have the expression 1 plus 3 plus 5 all the way to 2n minus 1 is equal to 2 plus 4 plus 6 plus 2n minus 1 minus 1. Just a lot of trails on minus 1s. We only add to 2n minus 1, not n, because the nth odd number is actually 2n minus 1. So we have all of these like minus 1, minus 1, minus 1s. And how many minus 1s are there? Well, there's n terms. I designed it that way. And we're adding 1 to each of the terms in the series. So like 1 plus 1 is equal to 2, 3 plus 1 is equal to 4, and so on. And since there's n terms, we subtract n times 1 once, so which is just equal to n. So therefore, 1 plus 3 plus 5 all the way to plus 2n minus 1 is equal to 2 plus 4 plus 6 plus 2n minus n. Alright, so continued. So now that we have this expression over here, 2 plus 4 plus 6 plus 2n minus n, we have to prove the sum of the first n even numbers is n squared plus n, if it is actually n squared plus n. So let's just assume that for now. So first you have to observe that the nth even number is 2n. Yeah, in these things I forgot to prove that I forgot to put the 2n at the end, but hopefully it doesn't obstruct the proof. So 2 plus 4 plus 6 all the way to plus 2n is equal to 2 times the sum of 1 plus 2 plus 3 plus all the way to n. We're just factoring out a 2 from every term here. So therefore 2 plus 4 plus 6 plus all the way to 2n is equal to 2 times n plus 1 over 2. We established that this thing over here is just actually equal to this right here. I think we assumed that over here. You see here. So let's continue on. We can multiply a 2 on. Let's just distribute this 2. These two cancel out, and we just have this nice expression here. 2 plus 4 plus 6 is equal to m times n plus 1, and that's after distributing the n is n squared plus n. So now that we've already proved that 1 plus 3 plus 5 all the way to plus 2n minus 1 is equal to 2 plus 4 plus 6 plus 2n minus n, So we've already established that this is just n squared plus n. So let's just substitute this into here. And once we do that, we get that 1 plus 3 plus 5 all the way to plus 2n minus 1 is equal to n squared plus n minus n, which is equal to just n squared. Thank you for watching.